Click for IB Biology. Here we're in carbohydrates, and we're going to take a look at the disaccharides. So more commonly known as double sugars. And in this process, we're going to see one sugar, one monosaccharide joined to another one to give this disaccharide structure. We'll focus on maltose and sucrose and very quickly take a look at some of their properties. Should you wish, there's a PDF in the description that you can download and annotate for your own purposes, and there's a quiz to check your understandings of the content. In general terms, what's going to happen here is we're going to form a dimer. So a monomer plus a monomer forms a dimer, and our two monomers are going to be monosaccharides. So for instance, if we do glucose and glucose, then the dimer that we're going to form is maltose. We'll take a look at sucrose later. And we focus in on these two groups here. And what we're going to see is what's called a condensation reaction, in which two hydrogens and one oxygen are removed. So you can see that one there and there. And we're going to connect the two molecules through these bonds here, satisfying their valency in the process. So that's called a condensation reaction because it yields water. Later, when we do things like digestion, we'll actually see us splitting this bond. That's known as a hydrolysis, so water and splitting idea, where we go back to the monomers. On the left-hand side of the diagram is the formation of maltose. And on the right-hand side of this diagram is the formation of sucrose. So for the moment, we'll stick to the left-hand side of the diagram. So you can see that I've used fairly simple diagrams to illustrate the two glucose molecules and highlighting the carbon 1 OH group and the carbon 4 OH group here. So we're going to remove the hydrogen and the OH group like so, and then that allows a bond to be made between here and here. So carbon 1 becomes attached to carbon 4 through the oxygen, and this is called an alpha 1,4 glycosidic linkage, or indeed sometimes a glycosidic bond. And that gives us maltose. So the structure here is maltose, with the formula C12H22O11, because remember, we have removed two hydrogens and one oxygen in the process, hence the name condensation reaction. Contrast that with the formation of disaccharide, which is a glucose plus a fructose. And in this case, the bond is formed between carbon 1, carbon 1, 2, 3, 4, and 5, and carbon 1 on the first glucose. So this is glucose and this is fructose. So glucose and fructose. And so here we have a 1,5 glycosidic bond. Maltose, if we look at the properties, maltose is indeed soluble, and it's also a reducing sugar. So perhaps if we think of that as meaning that it's both soluble and biologically, chemically reactive. Contrastingly, sucrose is soluble, but it is a non-reducing sugar. So you would get a negative Benedict's test with this one. Now this means that being soluble and non-reactive, this makes it an excellent sugar for transport. And we'll see later that sucrose is commonly transported in the phloem of plant tissues. Further links to videos as we move on now to consider the polysaccharides are shown below, links to the channel and playlists, and also the link should you wish to subscribe.